All right, we are going to work on our Chapter 5 review. And the first question simply asks who was the first person to talk about atoms in the 4th century BC. And we're going to call that man Democritus. He was a Greek philosopher who put together the first periodic table. This was Mendeleev. And he arranged it according to atomic mass. According to atomic mass. There are a few problems with that. The arrangement wasn't quite perfect. So the modern day periodic table was put together by Moseley. And he thought it would be a better arrangement and the patterns would be more clear and distinct if he arranged it according to atomic number, and that's exactly how we do it nowadays. So it's arranged by the number of protons, basically. Periodic table is arranged into columns, and the columns are called groups or families. Groups or families. Remember, columns go up and down. And then the rows are called periods, or some people call them series. And these are the ones that go across that way. Which elements are most chemically similar to magnesium? So I want to look at that family. I want to go down that family. It's in 2A, I believe. And that's our alkaline earth metals. So they're all metals. So everybody in that group is going to be similar to magnesium. So I'm just going to list them. I have beryllium. I have calcium, I have strontium, I have barium, and I have radium. And they're all in the family called alkaline earth metals. How did J.J. Thomson discover the electron? I said that he shot a beam of charged particles through a vacuum tube, which means all the air was removed so that nothing would interact with the charged particles. And he noticed the particles were attracted to the positive plate. So he thought that the particles must be negatively charged, and he called them the electrons. All right. What is the atomic mass? And atomic mass is the weighted average of all naturally occurring isotopes. So atomic mass is the weighted average of all isotopic masses of a particular element and then the question says, how is it calculated? And so we calculate it, and I'm going to just go ahead and erase this so I can write it up here, because you're going to need I'm going to need more room, and you've already gotten those answers, I hope. So let's get rid of that. And then we'll come up above this and answer it. Okay, so calculated by multiplying the percent occurrence times the isotopic mass. And you do that for all of the isotopic masses, whether you have 1, 2, or 3, or how many. And then these values that you get, these weighted values, are added together to get the atomic mass. All right, the units for the atomic mass are the atomic mass units, AMUs. All right. The next one says to define the word atom, and I said that an atom is the smallest particle that still maintains all properties of the element. Okay. So now I'm going to scroll down. So I'm going to go up here and hit the mouse. Come on down to isotope. Oops, messed up there. All right. So next thing is to define an isotope, and I said that an isotope is an atom or atoms with the same number of protons but differing numbers of electrons. Not electrons, I am so sorry, different numbers of neutrons. Hello. Different numbers of neutrons. Make sure you correct my mistake. I said electrons, and that's not what it should have been. It should have been neutrons. All right, so there's my isotope. We are going to talk about the 3 subatomic particles now. So we have the proton, has a positive charge. Located in the nucleus. Then we have the neutron, and it's spelled Neutron. It has no charge. It's located in the nucleus. And then it has the electron. And it has a negative charge. And it is located outside, moving around the outside of the nucleus. Okay. Okay, we did that. How do you determine how many of each is in a neutral atom? So the atomic number is equal to the protons which is also equal to the electrons, the mass number minus the atomic number equals the number of neutrons. We taught you ape, man. So here's A, P, E. So those are all equal to each other. Atomic number equals protons equals electrons. Man, mass number minus atomic number equals the number of neutrons. The nucleus of an atom is a densely packed center that contains protons and neutrons. Okay, let me see if I left anything out there. Nope. Okay. I'm going to stop and then go back and record another, start another one. We're going to start with number 12 on the other one.